This is assignment 8 in test prep, linear quadratic systems. So the idea with linear quadratic systems is that you set them equal to each other if they're both equal to y, and then factor that out and solve it for x. That you have two coordinates to find though. So factor that out, two numbers that multiply to negative 12 and at the same time add to negative 1. X minus 4x plus 3. So 4 and negative 3. But we need to find the y's. Actually, you can answer this without that. The first quadrant. So which one of those is in the first quadrant? C. So you can do that without doing any work if you know your quadrants. Number 2. So what's the distance between the two solutions? So two totally different problems here. So we have 4 and 10. You can put 4 into the lower one, and then you can put negative 3 as the other one into it. So set them equal, everything on one side, factor it out. That's actually, yeah, that's from the first problem. So we had that from problem 1. Find the distance between them. So you do x2 minus x1, negative 7 squared, and then y2 minus y1, so the square root of 98. 7 times the square root of 2 when you reduce it. Again, no calculator, so you got to go by hand on the square root reducing version of that, which makes that a little more difficult. Number 3, the solution lies in the third quadrant. That lies in the third quadrant. Again, you don't even need to do any work. Oh, well, you do. Is it B or D? Well, you could probably substitute in. It's not D because if x is negative 2, y has to be negative 3. You don't need to do anything except simply substituting in. B or D is the answer because you're in the third quadrant where both x and y are negative. So you don't even need that work. But set them equal to each other. I mean, otherwise, other than that, factor it out, get the x's, and then substitute into the linear one to get the y's is what you need to do. Problem 4, you set it equal to 4 because that's the x value of the the y value of the vertex. Factor it out, you get 2, 4. So x equals 2 at that vertex height, and then it's going to hit the ground at 4 if you're looking for that. So after 2 seconds. So you see the whole bit of setting them equal to each other is very important. So all three must intersect. So 1.5 about 2.1 is a good estimate on that. There are no points of intersection here. And here again, we want to do the distance from one point to the other. So square root of the x2 minus x1, that's 5 squared, plus y2 minus y1, negative 5 squared. So square root of 50. This is a calculator part, which cracks me up because it's harder than, or it's easier than the no calculator one was from before. So you need to know this distance formula. Let me just use my red ink here. Is pretty important stuff. And I don't think it's on that front page of notes that's on every test. So, gonna have to know that. And that is the 8th assignment in test prep, the math part.